Hello friends, today we will discuss a second case to improve the efficiency of a gas turbine power plant, that is gas turbine cycle with intercooling. So gas turbine cycle with intercooling. So in case of reheating we have two expansion processes, but in case of intercooling we have two compression processes. So consider the flow. This is flow diagram, this is TS diagram, ideal TS diagram for the intercooling, and this is actual TS diagram for the intercooling. So consider the atmospheric air is taken into the compressor where it is isentropically compression processes takes place from 1 to 2. So 1 to 2 is isentropic compression process, but in case of intercooling this compression process takes place between lower pressure to intermediate pressure. So this is lower pressure P1 and this is intermediate pressure Pi. So compression process by first compressor is from lower pressure to some intermediate pressure. So 1 to 2 is isentropic compression process. After isentropic compression process, that air is passes through the intercooler where it is cooled, the air is cooled. So cooling is takes place from 2 to 3 process. This 2 to 3 process is constant pressure cooling process. So constant pressure cooling process, and after that after cooling that passes through the second compressor where it increases the pressure from Pi to P2. So isentropic compression process 3 to 4, during this process pressure increases from Pi to P2, means intermediate pressure to higher pressure. So 3 to 4 is isentropic compression process in a second compressor. Now 4 to 5 again, after 4 point the process is similar to the simple cycle. So 4 to 5 is heat addition at constant pressure in a combustion chamber. Then 5 to 6 is expansion of a gases in a turbine, isentropic expansion of a gases in a turbine. Expansion takes place from higher pressure to directly to the lower pressure, means P2 to P1. So expansion of processes takes place and that gas is released to the atmosphere. So 6 to 1 process is heat rejection process to the atmosphere. So this is the ideal case. So one thing you have to keep in mind in case of intercooling, if the temperature of 1 and temperature of 0.3 is same, then it is called as perfect intercooling. So if in a numerical there is a word perfect intercooling, that means temperature at one point and temperature at third point is same, means compression process 1 to 2, after intercooling the temperature is similar to at the inlet of a compressor. So if T1 and T2 are same, then this is perfect intercooling. If word perfect intercooling is there in a numerical, that means we have to assume temperature of third point is equal to temperature of first point. Okay, this is the ideal case. Now in case of actual cycle, similarly for actual cycle, as I know, we know that, or as I told to you, if compressor efficiency and turbine efficiency is given to you, then it is actual cycle. So here two compressors are given. When two compressors are there, then two efficiencies are given to you, and in case of turbine, again a turbine efficiency is given to you. So in case of actual cycle, due to friction between piston and cylinder, due to friction, the temperature after the compression process or temperature after the expansion process is slightly greater than the ideal case. So here T1 to 2 dash is ideal cycle, 1 to 2 is actual compression process in a compressor 1. So 2 to 3 is intercooling, then 3 to 4 dash is ideal compression in a second compressor, 3 to 4 is actual compression process, 4 to 5 is a combustion chamber, heat addition in a combustion chamber, 5 to 6 dash is ideal process, and 5 to 6 is actual process. So by using this formula you can by using this concept you can calculate the work done by the turbine or work consumed by the compressor and efficiency of a gas turbine power plant. So to calculate efficiency we have to consider this work done, T5 minus T6, minus we have to add this compressor work and we have to subtract these two compressor work from the turbine work, and if we divide that net work output by heat addition, then we get the efficiency of a gas turbine power plant with intercooling. Thank you.